What is the minimum sample size required to estimate a population proportion to within 0.01 with 95% confidence? Now note there's 3 marks, so we've got an activity which I've actually got open over here that will do this, but you can't just simply crunch it in there when it's 3 marks. You've got to show what you're doing. So the first thing I'd probably do is copy in the formula. So I've got n equals z squared p 1 minus p over e squared. Now the minimum sample size is going to happen when p is 0.5, or at least that's what we have to do when we don't know anything about the p. We're going to have to take p is 0.5 here. So let's think about 95% confidence interval. So the first thing to do is go z-score, and it is the one that we've already got there. So I can go back here. So this is the value, and I'm going to give my Z95 value here as well. I'm going to say it's 1.959 and so on. And of course our E is 0.01. So we can substitute those values in, and so if p is 0.5, 1 minus p is also 0.5, and then we've got the 0.01 squared on the bottom, and of course now we can just get it from here. So the n is what we're trying to find. We've got that value. Our p is 0.5 and our e is 0.01, and we'll just solve, and it gives me 9603.5471, and so we would give 9604 as the answer. Identify 2 factors that affect the width of a confidence interval for a population proportion and describe the effect of each. Well, the obvious ones would be sample size, and larger will make the width smaller. And the other one would be the confidence level, and greater confidence will increase width.